Hi everyone, thank you for joining me today. My name is Stella Nyambura Mbau. I'm 32 years old and I live in Nairobi. I founded LOBA, that's bringing you this class, in partnership with Village to Nation, who facilitated this masterclass. I'll be your host for this session on climate change, the science, global warming and climate change. We'll also look at the relation between climate change and Earth systems, that is the biosphere, geosphere, and so on. So as we get started, I hope you have pen and paper, as I do. Please note down the key terms and explanations you learn here today for your own reference for later, so that you can look into some of these things a bit more. And also, I encourage you to engage one other person in this conversation, not only to pass the knowledge, but to better your own understanding so that you really know what you're passing on to others. If they don't understand what you're talking about, usually it means you need to work on your explanation some more. You can make reference to the Feynman learning technique for this. So moving on to what brought us here. I'm just gonna move to my next slide. Climate change is a global happening. It's difficult to understand what's happening here in Kenya in isolation from what's happening in Africa and the world. And this is why I've made sure to include views, perspectives from outside of Kenya, as you'll soon see. It's like trying to understand COVID in Kenya without taking into account what's happening in the rest of the world. It's almost impossible to picture that now, especially as the vaccines are coming. It's who got it first, where is it going? It's going to be first batch, second batch. You understand what's going on here when you have a better understanding of what's happening in the rest of the world. So yeah, but I have the sense that that's what's happening with climate change, the compartmentalizing, thinking about what's happening here or in other places in isolation from each other, which shouldn't be the case. So that it's a conversation for some people is wrong. It's a conversation for everybody. That shouldn't be the case. And so therefore the aim of this masterclass is exactly that, to get us talking about it without feeling like we can't or we don't know enough. Everybody started from somewhere, start from scratch, and you learn and you keep learning, and that way you become eloquent on the issue. So in the course of this month, we'll hold this class on Saturdays. The time 2 to 4 p.m. Nairobi time. That may change, so be sure to check the Village to Nation website for updates. Also, for you to access the class, I think you know by now that you need to sign up first. That's to mean 4 days, 4 sessions. The first will be on climate change. The next will be on climate justice, then climate risks, and finally climate action. Yeah, so today let me give you the highlights. We'll be looking at, this is a recap. We'll go through the science, I mentioned this before, global warming and climate change, then the relation this has to other Earth systems, the hydrosphere, biosphere, geosphere, and so on. So before we start, I'd like to know, before I do my definition, in your own words, what is climate change? You can go to bolev.com, as you see on your screen, enter the username LKE, Loboa Kenya, LKE050, and answer the question. I think that question is activated. So yeah, that's as I attempt to give you my own definition. We'll review some of the answers after this, so make sure to give it a go. Just checking that the question is, yeah, it's activated. So what is global warming? As you see on your screen, I just put down some basic terms that we relate to global warming. And I think this is one of the easy ones to define because it's exactly what it means. It's global and it's warming. So the questions are the why and what are the consequences, because if it didn't have any negative consequences, I don't think we'd be talking about it. It wouldn't be a problem. So there must be something that's happening with global warming for it to be a problem, for it to be a conversation that we need to have. So what is it? Global warming, the warming itself is because of carbon emissions. Carbon emissions, often we say, especially in the last couple of decades, is because of human activities. And these human activities are mainly linked to fossil fuel, the burning, the processing, and when you're fracking or drilling for oil, there's also natural gases. All of these, when burnt, emit a lot of carbon. So I think, just to give a bit of a background, I think we know that fossil fuels, those are that's a remnant of living things that were here a very long time ago. So with every living thing is stored carbon. So when you or a living thing dies, it goes back to the soil and there's a process of decomposition. And we have the different layers on top of each other and so on and so forth, to the point that you have something that died off millions of years ago is now really deep down in the earth, and in different forms. So you have oil, there's this gas, and yeah, it's a good source of energy. But like I said, every living thing has stored carbon. That means when you burn whatever this is, you're emitting the carbon that was stored. So the more we're doing that, going to fossil fuels for our energy source, that's what's happening. We're releasing more and more energy, carbon that is, into the atmosphere. So on the slide, we also have, yeah, so these gases, it's not just the CO2, we call them greenhouse gases. There's carbon dioxide, there's nitrous oxide, and there's methane. There's also water vapor, but that is more of the oceans because of global warming. The oceans release whatever water they have, and that's also contributing to the heat trapping effect of these gases. So if there wasn't such a saturation of these gases in the atmosphere, just imagine if the air was, well, a bit clearer. Just imagine something that's clear and something that's saturated. Something that's clear would mean if the solar radiation is coming in the clear scenario, solar radiation comes in and is also free to leave. And so therefore you have a better situation where heat and temperature regulation is happening, is frequent, is consistent. There's a sort of balance. When you look at the saturated scenario, here I'm talking about these particles that we have, that we measure in parts per million. These particles that are in the atmosphere that are causing the heat trapping effect, when you have those, instead of this solar radiation coming in and leaving freely, it gets trapped in these particulates themselves. So that's how we get the heat trapping effect happening. Whatever heat is coming in is trapped here, is not leaving. And so therefore, the atmosphere is getting hotter and hotter. Now, how does that affect Earth? How does that affect anything else? So why is that an issue? I think I'll go to, because I want the next point to be about climate change, so I will link that to climate systems. So when you have the global warming happening, the global warming effect, the greenhouse gas effect, what will happen is that I think we know how convectional currents work. What happens is that you have hot air and you have cold air. Hot air rises because it's less dense, cold air is dense, and so it goes down. And as long as you have these hot and cold, you will always have some form of balance, because there will always be some convection, some rotation, some displacement that will always be there. So when it's getting hotter and hotter, how that's affecting climate and our day-to-day weather is that, as it's the air and the wind is getting hotter, it means that how it used to move from cold to hot is changing. And with wind, for example, wind systems, they carry a lot of things with them. They also push clouds. That means if you're changing how the wind is moving, you're also changing how and where rain is falling, how often. So very soon you start to see that global warming, just the warming itself, has other very many consequences that are interlinked, and becomes a bigger problem when you start to think about it, because everything that is now on Earth, all the other systems which they have interactions. So one thing then affects the other and ends up being a big problem, is why we call it a climate crisis. So that's our slide 5. I'm going to take you back to the question. This is a question we have in Polev. That's polleverything.com, Polev. What is global warming? We're going to look at, let me just read out some of the answers that we have there. Not seeing it very clearly. All right. Took me to the exact same place I'm trying. Okay. In your own words. So the question online, in your own words, what is global warming? In your own words, why? Because that's how you should be able to internalize the definition, the understanding, in very basic terms so that you're able to pass it on to other people. So we have one person, extreme changes in temperature due to carbon dioxide increase in the atmosphere, extreme changes in temperature. I like that in the sense that they captured everything that is what you should say, really. What I would add is the extreme changes in temperature that has happened over a really long time, since, the industrial age. I would just add a timeline there. The other is warming of the planet that's causing climate change. Warming of the planet that's causing. Yeah, I like that one because it's really basic. That is exactly what it is. You can use whatever words to define it. Just as soon as you understand it, then you find your own words to explain it, so that other people can understand what you're saying and also be able to communicate it to other people. I think that's the main gap that we have. The communication isn't happening between, especially like in Africa, our rural communities are the ones that are most affected. But for example, in Kenya, I don't see that we're having climate change, the conversation in any other language but English. And that in itself is a problem. Because people in rural Kenya don't necessarily speak English or understand it. It's so that there's a really big barrier. So they're not able to access this information that they should. There's another one, increase of earth temperature. Increase of earth temperature. Again, correct. I like this because it's simple. Obviously, there's many ways I could add on to these definitions to make them better, but they are nail on the head. The final one, global warming, is the unusually rapid increase in Earth's average temperature. Okay, now this one tried to add a bit more context. Yeah, when you say average surface temperature, this is exactly what climate is. It is the change in temperature over a long period of time. So we're talking about averages like this decade, the last decade. It's a comparison of a much longer time scale as opposed to weather. Weather is today, in the afternoon, in a couple of hours, very short term. Climate is longer term. Yeah, I think I like those attempts. And actually, I really do. Okay. Let's go back to the slides. The next question before I go into my own definition. We're going to do this with every section where I look at what you have to say and what I have to say, see where those two meet. So again with this one, I'd like your opinion. In your own words, that is, what is climate change? You can go to pollup.com, enter the username LKE050 and answer the question. I've activated it. I'll give it a go in my own words, then we'll review some of your answers afterwards. So what is climate change? I think I mentioned this ppm is how we measure how much CO2 we have in the atmosphere. Like I said, there's many particles. This is parts per million. So you can get to find out how much CO2 we have in 2021 and compare to how much there was parts per million in the atmosphere in the 1700s. This is how we get to know that the amounts in the atmosphere right now are the highest levels we've ever had in history, I think, ever, of the planet. Yeah, and this climate change, I think I will go back to what I was saying about global warming. Climate change is what is happening to our climate systems. Climate change is a changing climate. If you've had climate change so much to the point it's lost its meaning, just remember it's the changing climate. And climate is the longer term, how the climate is looking is dependent on what it has been longer term, not the day to day experience. So changing climate, and we know that that is because of global warming. So the other thing would be, what are the effects? We already know the why. That's the global warming, the greenhouse gases. I defined the systems, the wind changing, the rain changing, and obviously when the rain patterns are changing, you also have the drought seasons. And a lot of that, I think I see Arctic ice melting. Yeah, that's to do with our hydrosphere. So the hotter it's getting, any ice that we have is going to melt away. That is going to lead to sea level rise, coral bleaching. I was trying to look for the word coral bleaching, biodiversity loss, because some of this weather, why it's a problem is because it's different. So every living thing has gotten used to its habitat and has adapted to its habitat with all the whether rain or moisture in the atmosphere or humidity, the heat. Everyone, everything has gotten used to where it is. So, for example, in the oceans, if it's getting warmer and the fish are used to a certain level of temperature, that means something's going to happen. There's going to be moving, either moving or in some cases where, I'm just using fish as an example, where fish aren't able to move, it might mean a die off, which, is why now this conversation then spills into a conversation about the sixth mass extinction due to climate change, because the climate of, in some really sensitive ecosystems where we have endangered species, for example, many trees and animals alike, wildlife, all of that, with the temperature increase, the climate change is affecting how these animals get their food, how often they get rain, for example, if we're talking about flora, how often they get their water, and how healthy basically life is generally. Yeah, how healthy life is strained because of climate change. For example, in the oceans and the coral bleaching, with the increasing temperature, algae, which is, we know, food for fish, algae doesn't do that well. And, as the algae is dying off or strained, coral reefs aren't doing that well either. They get their color, magical looking colors from algae. So if the algae is dying off, because just think of algae as little tiny trees. If they're not doing well in that temperature, then that means access to food for fish and anything else that feeds from algae is strained. So fish end up with no food. Okay, obviously, they have to move or adapting in some way. And if not, if these changes are too much for them to handle, might lead to, die-offs. Yeah, I think food scarcity, food insecurity, and water scarcity have become a very common conversation. So I'm sure when I say that, you know what I mean. And that is all due to the changing climate and how, the interaction, what balance was there is now really not there. So things aren't working as they should. And we expect that, animals in the wild will have the same problems. There are pressures that we are putting on wildlife, for example, very directly. Deforestation, cutting down trees, change of user on our land. Land governance has been an issue. So these are the direct ways that we affect wildlife and life in the wild and ecosystems generally. But in an indirect way, climate change, because of our activities, our carbon activities, causing climate change, and that is indirectly coming back to affect these same sensitive animals and sensitive ecosystems, the flora and fauna. It's general, basically, life in general. And that's why I have biodiversity loss there. I think to do with on water scarcity, I have a video from Lesh, and I'm gonna play it right now. It's very short. Let's see if I can share video.
Hello friends, 15 years ago, you could not walk over this stone. This rock was covered by water. But this time, this is February, and this river is dry. This river used to be an all-weather river which used to flow throughout. But due to global warming and climate change, today this river, it has no water. When we are talking of climate change, it is real. This is Mwakajo River, which is right now dry. It's really agonizing.
That is Lesh. And I'm gonna be sure. Blesh is a farmer he's a Maasai farmer. And I've been on a presentation. We participated on a conference together, Soil Not Oil. And I didn't know that Maasais did farming. Ignorance. Yeah, so he was giving a talk on agroecology and technologies that he is using. So I think we're going to have him share a bit more later, I think on our last session. He's a project coordinator at Garden of Hope, a community-based organization That video is from back in 2017. Now, in 2017, Kenya's water reserves were strained to a point where we came really close to our own day zero. If you know about the Cape Town equivalent of day zero, where Cape Town went dry, it's really a point where even government starts to really, it's like a sense of panic or concern, heightened sense of concern, because how do you do without water? You know, yeah, so here Mlesh was practicing a form of community-based data collection. When you're looking at delivering early warnings, even for climate events, sometimes, especially in Africa, because monitoring systems are so limited, sometimes community-based data collection is really useful. As I move on to my other slide, I'd like to leave you with a rhetorical question. So this is after defining global warming and climate change, we talked about human activities being the main cause, but which one activity stands out as the most destructive? I believe I've mentioned it a couple of times. So what would you say is without a doubt the main source of carbon emissions? That's what I mean with the question. As individuals, there are various sources of emissions. You could think of, there's a million ways that we are emitting as individuals. If you're driving your car, we run on fossil fuel. We run our cars, most of our cars, on fossil fuel. It's the food we eat, and you could break that down to very many things. How the food was grown, if you use fertilizers, what they imported, if you moved the food from the farm to Nairobi, how much, what footprint do you have? There's a lot of aspects that we might not think about, or we've gotten used to things as they are so that we don't think about them. Yeah, I know a couple of people who've gone vegan for this reason, or vegetarian, whatever version, and various versions on minimalism, because knowledge about climate change is the kind that has to come with behavioral change. If that hasn't happened in your life yet, where you learned about climate change and nothing has happened, you haven't changed anything, I would say go on to study the science some more. My mom is in the kitchen, you're going to hear some dishes knocking back and forth. In a conference I was watching, I remember someone saying, if you know about climate change and you're not in some state or form of heightened concern, then you don't know enough. On the other hand, when you have the full picture, it's very easy to give up. You've heard of people living in bunkers. You've heard, many stories. Many people have given up. When you understand how much needs to be done and how little is actually being done, yeah, anybody could lose their mind over that. But the point is to be objective, to find middle ground where you know that you know what you know, and still are optimistic, still somehow find the need to push for change, because we're the only ones who can do it, and we don't exactly have time. I'm not trying to be alarmist. It's just the truth. But there is a chance to change things. It is possible. So it's important for people, even when you know, there's many kids who are getting very anxious and depressed, growing up feeling like we have trees now, but maybe when I grow up, there won't be any trees. It's been reported that kids are actually starting to internalize this in that sense, which it really isn't fair, but you know, we are in a position where we might be able to do something about it, and that's the point, to try and stay positive. Mm, yeah, so I would like to go back to the poll of question I mentioned earlier. What is climate change? But let's do that after these videos. I have Derek Nyamedi. He's Ghanaian, a Pan-African who is interested in the various aspects of social justice, including climate justice, and is involved with various movements, Fridays for Future in Ghana, and Polluters Out. Yeah, he's explaining what climate change means to him.
Good day, ladies and gentlemen. My name is Derek Nyamedi, speaking from Ghana, and I wanted to elaborate on the issues of climate change and what it means to me specifically. And to me, the issue of climate change is a very important issue that needs to be tackled by all and sundry, and we should all be able to contribute our path, we should all be able to contribute our quota to the fight against climate change in any way and manner that we can, be it through writing, through street protests, through online protest, and any other form that we can be able to take. But first of all, we should be able to first send out information to our friends and family and educate them about the issue of climate change. Thank you.
So that was Derek, and now I would like to go back to the poll. We had a question: what is climate change? And we wanted to know what various people thought. We had this poll out during the week, so we've had some people respond. So let's have a look at those answers. I'll just read them out. In your own words, what is climate change? All right. It is the periodic modification of Earth's climate brought about as a result of changes in the atmosphere, as well as interactions between the atmosphere and various other geologic, chemical, biological, and geographic factors within the Earth system. This is by Pauline, my God. All right. Yeah, she explained it. It's too technical, but it's perfect. I mean, that's how she would say it. So, yeah, we have another changing of our planet Earth. Changing our planet. That is very abstract. Yeah, it needs, because changing our planet Earth does not say why it's changing. It's too obscure. Also, what is the climate change, global warming? Yes, many people link the two in that sense. I mean, it could be that global warming, you could see it as global warming has led to climate change. Because it is the cause, you could also make the leap that global warming is climate change. I feel to directly relate them like that is it needs a bit more explanation. It is direct, the correlation. I don't think one is the other. Okay, so maybe they just needed to add a bit more words to it to make it clear. Final one. It is the changes in the weather patterns globally due to various factors such as human disruption of the Earth's surface environment, rising sea levels, lower food production due to soil erosion and contamination. I feel like there's been a lot of mixed. The first part was perfect. It is the changes in the weather patterns globally due to various factors such as human disruption of the Earth's surface. I feel like it's more disruption through our carbon emissions, not specifically Earth's surface, but I understand what they mean. They're probably referring to human activities. Like when you say drilling, is that on the surface? Maybe still on the crust. Anyway, well, some. So, okay, no, that was disruption of the Earth's surface or environment. Yeah, okay, that brings it back. And then rising sea levels. Now, this part was more, I think they were explaining the effects of climate change. They mixed it and made it, yeah, these are two different things. Rising sea level, lower production due to soil erosion and contamination. So part of that is climate change, part of that is a direct impact of human activities, direct, like the soil erosions because of farming. We farm on the hillsides, we farm everywhere, loosening up the soil, and using pesticides which are not good for the soil. Yeah, I think we have what we wanted from that question. I love the answers. No, there's no right or wrong answer. It's just how you say it, what you build the answer with. It's not the words you pick. We speak differently. So, as you saw from those examples, no one is saying the same thing the other person is saying, but they're not completely different from each other, which I think is interesting to see. Back to the slides. So I think now I would like to give a review of what we've covered so far. Some keywords, descriptions that we've made or come across. So the first is global warming. That's what we started with. Think greenhouse gases. Again with the dishes. Yeah, global warming. Think greenhouse gases and think heat trapping effect. Yeah, I think that is a way to think about global warming. Climate change, think the changing climate systems and the consequences of that. That is the droughts, the floods, consequences of that include when you have droughts and floods, you have water scarcity and food insecurity, you have biodiversity loss, and so on and so forth. You can also think massive extinction or endangered species. Yeah, and greenhouse gas and CO2 is the one we speak of most. I want to just point out that CO2, just like oxygen, has been there in the atmosphere always. I think that's life. For you to have life, some gases like carbon dioxide, oxygen, methane even, there has to be some level of, that's how you know that there's life on a planet. Some of these gases have to be present. However, the point is, when we go back to the ppm, the parts per million, it's the levels of which are out of control, so much so that there's no balance anymore. And that's a big problem. Yeah, I think that covers that. So we're going to take a short break while I'm back. Let me share our slides once again. So before my next section, we'll talk about the relation between climate change, the other Earth systems, that is the biosphere, geosphere, hydrosphere, all of those, atmosphere. I would like for us to answer this question. I just picked one of the spheres, the geosphere. I think it's, well, being an African Kenyan, I think how climate change is affecting our soils, agriculture, which affects our economy. It looked like the one that I wanted to ask in this section. So I've just had this one question for the poll. In your own words, how do you think climate change affects our soils? So go to pollup.com, use the username LKE050 and answer the question. It's activated. I'll have a go myself. We'll see how climate change affects oceans, life, flora and fauna, the biosphere in general, and so on. Then we'll review some of your answers afterwards. So to start with the hydrosphere. Hydrosphere is everything that is to do with water. I think that is rather obvious from the hydro part. So that means the Arctic ice, water vapor in the atmosphere, that is also part of the hydrosphere. And so how are our oceans, rivers, even the moisture, water moisture, how are our Arctic icebergs and all those Arctic shelves, how are Arctic shelf, how are those being affected by climate change? So I would like to start by saying, let me see, I need to. I just pointed out some of the main points that people discuss when you're talking about the hydrospheres. And what's happening to the oceans, I think, is even at a larger scale. So you may have heard some of these things. I think I mentioned algae. That is how fish survive. That's their food. The temperatures are affecting how algae is growing, where it's growing. So if algae used to do very well here in Nairobi, for example, just giving a weird example, if algae used to do very well in Nairobi and the temperature started to change so that it's getting hotter, but it's colder somewhere in Mombasa, the algae could move towards Mombasa, which means the fish that eat this algae either move or find another source of food. And also the algae could move or not, and if the algae stays in Nairobi, it probably dies off, because if you're not used to a certain temperature, then it affects your metabolism and how your energy expenditure, how you live your life. So we're talking about algae not doing well, and that is food insecurity for fish and other sea life. So that is due to the increased temperatures. Now, our oceans trap carbon emissions, where the atmosphere meets oceans or water. That is a level of the interface. The interaction there means carbon dioxide is absorbed, that then becomes carbonic acid. So our oceans are a carbon sink. However, okay, before we go to the however, also like I explained with the wind systems, convectional currents, hot air and cold air, and how those move displacing each other. So therefore, so that way you have some form of balance. It's the same way with ocean currents and water, as you can imagine. So often what happens is at the surface of the ocean, because of the exposure to air and wind, hot air comes up, cools down, goes back down, and as the water down there gets warm, it rises, cools down, and comes back down. So there's a form of ocean currents moving, and not just this vertically, there's also horizontal movement from the poles to the tropics, because the tropics are warm, and at the pole is cold. So there's also, that is the main movement. That is what is not necessarily vertical. It's just currents moving from one place to another, displacing each other, cooling off and coming back down, getting warm. And this is how oceans help regulate temperature on the planet. So as it's getting warmer and warmer, it means at the surface where you expect that this water is going to cool off, what's happening is that that's not happening. If it's not cooling off and that is consistent, that could be a very big problem, because it's important that those convectional, the movements happen. That's how we have balance. Every living thing in the ocean depends on that. Yeah, so it's important that the heating is not as we're experiencing it now or gets worse. Because I've also come aware of this very recently, it could, if there's no movement, so the layers of the ocean get stagnant, not moving. We do not want to get there. That thing is that there's ocean acidification. Acidification is because, like I mentioned, carbonic acid, when CO2 gets absorbed, if more and more of that has happened, because there's a lot of CO2 in the atmosphere, so a lot more is being absorbed. What's happened is that the oceans are becoming acidic, and that is because in carbonic acid is I think a hydrogen ion, and that is how you measure acidity. The pH of anything is how many hydrogen ions there are. So when you have more CO2 being absorbed, carbonic acid is being formed, you also have more hydrogen ions in the ocean, in the water, and that means the pH is dropping. The pH dropping means the ocean's getting more acidic. Now, this is, again, not good, because the more hydrogen ions you have as free agents, or whatever you want to call them. So crabs, anything that lives in a shell is in trouble, because the calcium carbonate that makes up for the shell, one of those components are, the hydrogen has a high affinity for one of those, I think the carbonate. So instead of these crustaceans and crabs having, the shells are part of their extension. It's like our legs or something, and that's how they stay safe. If they see a predator, they go into their shell. That is how they've adapted to living in the places they live in. So with more hydrogen means that their shells, because of this high affinity, the hydrogen is going to take, I think it's a carbonate from the shell of these organisms. You know what? I'm going to look that up just now, just to make sure I'm not lying. Just to make sure. Hydrogen and calcium. The carbonate from the calcium carbonate is more attracted to the hydrogen ions. I was just had to check. Don't want to lie while I'm doing a class. Yes, so that means anything in a shell might find itself without its shell. That is, I cannot tell you how. It's depressing to think about. It's really, really bad. Yeah. So can you imagine how many things in the sea live in shells? Even just snails or slugs. We have those all around. And to think of them being deprived of, that's literally their home. There's that tiny thing that carries their bodies. So yeah, having hydrogen ions in the ocean is really not good. And that's how we say that the oceans have become more acidic, the hydrogen ions. That's how you measure your pH. So pH is low, hydrogen ions are high, this acidification is happening. Yeah, I think I mentioned the sea level rise. And increased temperatures. There was something else about oceans. The oceans, pardon me. The oceans are able to absorb the CO2. They are able to provide us that functionality as a carbon sink, as long as they are not warm in themselves. When they get warm, it's easier for them to release the CO2 that's stored. So we're in a time where the oceans are still absorbing, especially at the poles. Like I said, as long as the ocean water is a bit cooler than what's the atmosphere, the absorption can happen. Now, with our poles getting warmer and warmer, means at some point our oceans will not be absorbing any CO2, and what will happen instead is that they start to release the CO2 they have stored. We don't want that. Yeah. So there's a lot of, and when you start talking about these, we already have a warming planet, but there are other things that start to contribute to that momentum. They feed into that loop so that you have reinforcement, the no balance. In fact, it just starts to gain its own momentum like a domino effect. And where you had warming from the oceans, because if the oceans are not absorbing the heat and they're not helping when they release the CO2, we have CO2 in the atmosphere, then the oceans are adding to the warming. When you have that and the atmosphere itself, and we have our contribution, and the CO2 in the atmosphere is not going anywhere. So we keep on contributing to it. And other things like soil start to release their own CO2. So that situation, we call that a feedback loop. If you've heard of climate change and feedback loops, that's what it is. So we know what's warming, but then other things, other systems start to reinforce that loop. Yeah, that's what we call feedback loops. That's also a term you're going to see a lot when you're looking into climate change. Let's move on to geosphere. Now, I said that I would specifically pick soils, but the geosphere is everything rock, soil, that, yeah, something geological. The fossil fuels as well, crust, magma down in the earth, all of that is part of our geosphere. But I wanted to focus on soils because we have a very direct, everyday relation with soils. Yeah, I have SOM there. That means soil organic matter. And now the soil organic matter is, think worms, think ants, think microbes, microorganisms. There's a lot of things that live in our soils that give it its soil organic matter, the quality that it has. The more matter you have, SOM, the better and healthier that soil is, and is what is part of agroecology, trying to achieve good soil management, to achieve good soils, good healthy soils. That's the only way you grow good healthy food. And this is definitely meaning no use of pesticides. There are natural options. And for small scale farmers, these natural options work best, better than pesticides. Pesticides kill the soil and make it dry. Well, when you're killing the soil organic matter, like I said, these are microorganisms. They give it the ability to consolidate. They give it its the moisture life basically in soil. So if you're using pesticides, those are not good for, just imagine being sprayed on pesticides. If it's not good for you, it's not going to be good for the matter, the organisms in the soil. So if you're depleting your soil organic matter and that good healthy quality of soil, it's going to get drier, which is what happens when you use pesticides. And as you use more and more pesticides, your soil is less and less healthy, which means less and less able to give you food. Yeah. And we have the term desertification there. That is part of pesticides could be contributing to a problem of desertification, because if using pesticides means that the soil goes dry, and again, when someone's using pesticides, I think there's this an imagination that if I use pesticides, 10 grams, for example, of pesticides, if it doesn't, if the soil gets used to the 10 grams, then I should upgrade that to 20 grams. You find that people using pesticides continue to use more and more pesticides. This isn't good, it's not healthy, as I've explained. And if we continue to do that more and more, the soils are losing their soil organic matter. And there's a place where now that could lead to desertification. The other thing that could lead to desertification is soils are a carbon sink, again, just like oceans. That's because when you cut down a tree, it falls down to the ground, it starts to decompose. You have the organisms, the microbes, the soil organic matter. They know how to deal with that. And that's how the tree is, like we say, when people die, they go back to the soil, and the tree goes back to the soil. The carbon that was trapped in the tree, it goes back to the soil. Everything that dies goes back to the soil, which is why we talk about we should be very careful about peatlands, marshlands. The soil holds a lot of carbon because a lot of, I mean, if you think about it, everything that dies goes back to soil. So there's a lot of carbon stored in our soils. And it's important that it stays stored there. And it's possible that as we're farming, not possible, it's happening, that when we're farming, when you're loosening up the soil, you expose the carbon in the soil so that it burns off. When it's exposed to oxygen, it burns off as carbon dioxide. Now, you cannot say stop farming. It's difficult. So many people depend on farming. So the point becomes, how do you do the farming in a way that is good for the soil, that is not creating a problem? Because that's what you could find is what is happening. As long as you're farming, you're toiling, you're loosening up the soil so that you can come plant seed. We've been programmed to think that's how you're supposed to farm, and that's what everybody's doing. So we're releasing the carbon that is in our immediate surface as long as we're farming. So there's I think it's called no-toil farming. There's also people who just chuck seed into the farm. It sounds very haphazard and not organized, but if you could seed balls, you get soil, you stick your seed into the soil, you could add other things to the soil. There's a way to make seed balls, and then you throw it into your farm. It feels a bit disorganized for farmers today, but you can do it in an organized manner so that you're not necessarily contributing to a problem. Yeah, so the conversation about our peatlands and marshlands is very sensitive, because you'll find even here in Kenya we have a problem where you find people want to construct, to build malls next to riparian land, those kinds of places where there's an interaction between the hydrosphere and the geosphere is very sensitive, because the carbon in that form is, it's up for release as soon as you start to disrupt that ecosystem. And marshlands are actually very important. We have a lot of farmers who grow their food along rivers, especially at the coastal areas. If you have a river that's flowing into the ocean, you'll find that in some of these or most of these coastlines, either there's going to be mangrove or some papyrus reeds, some form of growth at that point of interaction. And that is really good. That is how people on one side, on the river side, are able to do farming, where the ocean is probably salty, because this marshland is able to think of it as a sieve. It holds back the saltiness, anything in the soil, in that water that is not supposed to come through to this other side. That's exactly what the marshland is doing at that point. So we need marshlands. These farmers need those marshlands. We need them because they store carbon. And as long as we leave them as they are fine. And that ecosystem is that way for a reason. The thing with peatlands, again, I think in permafrost and in some of these places that are, permafrost specifically, because the more the Arctic is melting, there's a lot of the black carbon. There's a lot of other things that could be, a lot of carbon could be released just by the ice melting. Yeah, so that's permafrost. We have peatlands as well, where you find wildlife died either from drinking water, maybe the water was polluted. So around these areas, a lot of carbon is stored. Yeah, I think that's most of it to do with soil. It's important that we realize it is a carbon sink, just like the oceans. So we need them. But if we don't treat them right, then they feed, again, the feedback loop. They start to feed into it. So in these different systems, if we are not careful, which we haven't been, it's already happening, that the global warming is being reinforced by other things that are happening to the earth systems. I think enough of soil. Yeah, we have a video from Saini. I'm just going to play now. So Saini is going to sharing his views on how soils are affected by climate change. He's passionate about agriculture, soil chemistry. He farms himself, and he's engaged in climate action with various organizations, Extinction Rebellion, as well as Polluters Out and others. And I think his activism is African, is global. He's very aware of a lot of things. So I like listening to some of these people. The more you're listening, the more you get educated. You know how to communicate the ideas that maybe you're not able to just yet, but using other people's explanations makes it easy. Yeah, so I like to listen to other people's opinions as well.
Hi, my name is Saini and I am from the Republic of the Gambia. My topic of discussion today is how soils are affected by climate change. You may know that after ozones, soil is the second largest natural carbon sink, surpassing forests and other vegetations in its capacity to capture carbon dioxide from the air. Soil moisture have significantly decreased in many parts of the world. Continuous decline in soil moisture can increase the need for irrigation in agriculture and leads to smaller yield and even desertification, with a potential dramatic impact on food production. Climate change in seasonal temperature can also shift the annual cycles of plants and animals, resulting in lower yield. With the expected population growth, world food production need to increase rather than decrease. This hinge largely on maintaining healthy soil and managing agricultural areas sustainably. At the same time, there is a growing demand for biofuels and other plant-based products driven by the urgent need to replace fossil fuels and prevent greenhouse gas emissions. There are various reports that highlight the impact and vulnerability of soils related to climate change, including erosion, which can be accelerated by extreme climate events such as intense rain, drought, heat waves, and storm. In addition to causing the loss of area of land, rising seas level may change soil in coastal areas or bring contamination including salt from the area. In relation to land use, climate change may make some agricultural areas unusable or less productive. As the global temperature increases, the permafrost melts. This thawing causes the organic material trapped in the frozen soil to disintegrate, which can lead to the release of massive amount of greenhouse gases into the atmosphere, which could hence lead to the accelerating of global warming for beyond people's control. Tackling the climate crisis with soil, there are various scientists and activists that has been calling for the defending and restoring of forests, peatlands, mangroves, salt marshes, natural seabed, and other crucial ecosystems to let nature remove carbon dioxide from the atmosphere and store it. Restoring ecosystem could also support biodiversity and enhance a wide range of ecosystem service, including cleaning air and water and providing people with enjoyable space for recreation. Despite the uncertainties, restoring ecosystem and providing soil quality could be a very cost-efficient measure in terms of climate action, with a triple impact. First, growing plants remove carbon dioxide from the atmosphere. According to FAO, restoring current degraded soil could remove up to 63 billion tons of carbon, which will offset a small but important share of global greenhouse gas emission. Secondly, healthy soil keep the carbon underground, that many natural and semi-natural areas act as powerful defense against the impacts of the climate crisis. According to FAO, higher atmospheric CO2 concentration concentration increases growth rate and water use efficiency of crops and natural vegetation, insofar as other factors do not become limiting. This is talking about how the concentration of CO2 can increase the rate of which we use water, thereby making the water capacity in the soil becomes lower. And in many parts of the world, particularly sub-Saharan Africa, we've been seeing how water is diminishing. The water level is really diminishing and soils are becoming drier due to soil temperatures and global temperatures in general. So that itself is threatening food security in sub-Saharan Africa, and many people are going hungry. The UN released a report saying that some 820 million people go to bed hungry, and with climate change, this will increase, thereby making the UN set target for zero hunger by 2030 difficult to achieve.
Oh wow, I like that so much. Yes, he did what he does best. He spoke about soils passionately. Yeah, I think he mentioned peatlands. He mentioned the soil organic matter. When you have soil organic matter, like I said, the soil is able to hold moisture. When that's when you have less and less soil organic matter, the soil isn't able to hold water, is why it gets drier. So you can imagine when it floods, the capability, there's all the conditions are right for soil erosion because this soil cannot hold anything. And if it's dry, it means it's not supporting grass or trees, anything to hold the soil in place. There's a lot of things, but I like how he explained it. And he included all all the important things that you should talk about when you're talking about um, climate change and its effects on soils. Saini, I think, is 24 or 25 years old. Yeah, these youngsters keep amazing me with how much they know. So next we have climate change and how it affects the biosphere. I've stated here biodiversity. Yeah, because it's affecting life and chances of life and who survives, who doesn't, who's going to struggle more than the others. So I think biodiversity was important for me, so I put it there. Polar bears, I've listed them there because, you know, their habitat, the Arctic ice melting, that's their home. So when I talk about um, how different forms of life have lived in one place so much so that they've adapted to that place. When the Arctic ice is melting, polar bears will not have a home. We've seen skinny ones on the internet, you know, because that's how they also feed. Yeah, so back to the issue of food insecurity. When how these habitats look is changing. It's changing how anything grows there, and most things feed off of something else that is either uh, growing from the ground or is eating that which is growing from the ground. If that which is growing from the ground is scarce, then you know that chain, the whole chain, is affected. Yeah, which is bees. Bees is important. It's an important conversation. We have bees on the compound in my parents' compound, and they. I don't like the conversation of getting rid of bees, but you know, if they sting someone, you could understand why they would want them gone. Yeah, but when you think of the bigger conversation of we need bees so that we can eat, to pollinate our food, it's bees and all these insects, birds, everything. That ecosystem, we need it to be able to eat. I think bees are very quickly facing a challenge. yeah, if everybody's thinking, they might sting me, let's get rid of them, then yeah. Yeah, so this is where the sixth mass extinction comes from. It is the conversation behind what climate change is, these challenges that it's posing on things that are living, on ecosystems, and yeah, if water isn't there and there isn't food, most of these animals, let me say wildlife, for example, even the bees, they're having to adapt. The changes are so fast. Adapting that fast is not natural. Usually these changes are gradual, but climate change and the warming is happening is too fast. There's many changes, there's many layers to this climate change event that that are catching many animals and insects, everything that's living. Most of these are being caught unaware and ready. If you're not able to adapt in time, if you're not able to adapt the right way, yeah, it's going to be, we're looking at the sixth mass extinction. You can look that up. So we have another video from Cinzia Alberti. She's a renewable energy expert from Hamburg, and she hosts a podcast that you should also look at. She's interested in stories of climate justice, and she's going to communities that are at the front line of some of these injustices, like to do with pipelines, setting up pipelines for fossil fuels. It all goes back to fossil fuels, this conversation somehow, and how they're really not compensated. There's no way to compensate someone enough after you've taken their land, their home, to build pipelines. There's no compensation. And to think that that is then leading to climate change. So you've taken their home and then they're having to deal with the consequences of a bigger problem. It's, yeah, when we say injustice, it really means injustice. So let's listen to Cinzia.
Hi everyone, I am Cinzia and I am Italian, but I currently live in Germany, in Hamburg. With this video, I want to give you my perspective on how life on Earth is affected by climate change. There is a very delicate balance that regulates life on Earth. Life of human beings, animals, but also trees and all types of vegetation. We humans as a species, especially in certain parts of the world, separated our lives from nature. And we treated nature as something that we can only extract from. Instead of thinking of human life and all other species as part of a unique life, as part of a whole. This behavior, perpetuated in time, led to irreversible damages that in the next decades will reveal themselves in a catastrophic manner. As of today, we can even imagine all the possible ways in which we disrupted this delicate balance. I think, for example, at oceans that contains millions of species, a lot of different and important forms of life, and our oceans have the capacity of absorbing CO2. This capacity, though, is already saturating. The CO2 concentration in the atmosphere is increasing so much, driven by emission caused by humans, that is forcing the oceans to now absorb more of this gas. The result is acidification of seawater, with immense impact on marine life. This is only one of many examples of how climate change caused by human activity has disrupted the delicate balance of nature. I believe that we should restore our relationship with nature and really act now to at least slow down the huge disruption that we are responsible for. We can do that not only trying to do our best in our everyday life to respect nature, but most importantly, I believe, we have to hold big corporations, big polluters, and governments accountable for their responsibility.
That was Chinzia again. Um, you find that the more you listen to these conversations, there's a consistent messaging, um, and that's just what you need to be tapping into, so that you can also, speak about it in your own way. Those are very different people. Um, as long as you have access to the information, it's going to be consistent. Yeah, because that's how the truth works. It's consistent. Here we have climate change and the atmosphere. So, how does climate change affect the atmosphere? This one I felt was a bit tricky. It was a bit tricky for me, but I'm still going to give it a go. Um, when I wrote think insulation, that's what the atmosphere. That's how it works. I remember giving the analogy of clear air and saturated air. Saturated air, clear air. You have solar radiation coming in and leaving. It's not that direct. Yeah, when I say think insulation, there's a lot of that harmful direct radiation that's blocked out. Yeah, so that's our atmosphere. That's what the atmosphere does for us, protecting us from extreme radiation. The saturated example, where this insulation is on another level. Yeah, we need the radiation that's coming in to leave for regulation. If it's trapped in, then it's like choking. It's supposed to leave. If it's not leaving, there's going to be a situation of, I can only think of choking. Yeah. And that's why I have health risk there, because with all the CO2 in the atmosphere, the water vapor, all of these, if the parts per million of each is increasing, that's affecting the air we're breathing. It's going to have an impact on whether we walk around with, I don't know what kind of gas tanks or oxygen tanks. I really don't know. It's not going to be masks, I don't think. The other thing is the interaction between the atmosphere and most of the other spheres, to me, feels like that's the one that is really more freely moving. The interaction is more flexible. So when we're talking about how wind systems are changing, it could be, I've read a couple of stories in the very recent past that are point to this exact thing. So changing wind systems means that if wind used to move from east to west of the Sahara, then people are used to, if there's dust in the Sahara, people in the west are used to getting this dust, maybe from the months of March, April, June. But if there's a change in wind systems, I read a story where some dust landed in Germany. So you see, in that case, you can look at it as pollution. This is dust that is going to a place where it's not expected, hasn't been there before. There's various ways to look at it, but it's not normal. That's not what you expect, but that's what climate change is. We're going to see a lot of these weird things happening. The one, I think this past week also, some wind, probably from Sahara still, from the south, blowing up into Europe. And there was, I think, the French were doing experiments into radioactive systems in some desert somewhere. And wind blowing up took this radioactive elements to some other place. It easily becomes, I think pollution is the right way to look at it. It will have health implications. You know, because maybe you left the desert and those radioactive things there thinking it solved a problem until climate change. Yeah, I think, yeah, it's interesting in that sense. It's moving all over the place. People banning palm oil in Indonesia and haze reaching Malaysia. You know, places that are far removed from where the activity is happening. Through air, that movement becomes a lot faster. So this is the atmosphere, our troposphere down here. The air and how it moves is in itself could make an event such as forest fires and the smoke. That smoke could travel a lot further than where the burning is actually happening. So in that sense, a problem that is probably geologically, you know where it is, spreads a lot faster. And yeah, I think the atmosphere, depending on what particulates we're talking about, I know you're hearing sweeping. As long as the particulates we're talking about are greenhouse gases, there is one of the entities of sulfur, sulfur oxide, is what they talk about when they talk about blocking off solar radiation to control heating so that we get rid of climate change. So just managing solar radiation. There's various ways of that you could do that. I've had conversations about spraying substrate into the atmosphere so that this sulfur oxide blocks off the radiation. So some of these particulates that we have in the atmosphere are not that bad. Yeah, so it depends on which is which. Some accelerate, hold on to the heat so that global warming becomes even more real. Others, like the sulfur oxide, could actually help block off the radiation. Yeah, so how you could do that is get on a plane, spray some substrate up there. The issue with that is it will run out after some time, and it will not really have solved the problem of climate change. As long as people continue to use fossil fuels, it will just have given you a cooling effect. It will not have solved the problem. Others have talked about, every time through shipping, every time we're shipping something, ships can release some of this substrate into the atmosphere. And I think ships also do that in themselves. They contribute to carbon emissions. There's also something they emit that is probably doing the same effect of blocking off some of the. I vaguely remember something I read. But yeah, it's I find it interesting to think that the air we breathe, we take it for granted, but it could have such a bad impact and very fast, direct impact on our health if the quality of the air we breathe is not good air. So you can think of these, the carbon, the greenhouse gases. If their levels increase, you can start to think of them as a pollution in themselves. Yeah, as long as they tip off the balance, like I said, wind moving with dust in a different direction qualifies for pollution. So I feel like we can now look at the question I asked you before I started talking about the spheres, the relation of climate change, the relation climate change has to Earth's systems. Yeah, this question went specifically to the target was specifically soils. So again, we're going to go to Paula, have a look at the question, how do you think climate change affects our soils? Let me read some of those answers if I can find, where is it? Some windows are hidden. Seen it. Yeah, I'm sure it's not. Let's see. We're almost coming to the end here. So this is our final question of the day. And I'm just looking for the responses. We have pesticides reduce. How does climate change affect soils? Pesticides reduce the organic quality of soil. That is more human impact on soils, direct. I understand that climate change is a bit indirect. Pesticides is direct. Pesticides reduce the organic quality of soil. So that is not exactly answering the question. It's hinting at the broad general issue of soils, not exactly how climate change affects soils. Second is soils are a carbon sink. Global warming makes soils release CO2 as opposed to store it. Soils are a carbon sink. Global warming makes soils release CO2 as opposed to store it. Yeah, we've talked about that. That you could say is one of the ways climate change affects soils. Warming means that soils lose moisture. They have a question mark at the end of the statement. Warming means that soils lose moisture. Yeah, I think anything you heat will release whatever moisture it has in it. So yes, and that's linked to the conversation with desertification, some aspect of it. That was good. All right. So let's have a look at, let me go back to sharing. I think I am. Review of that section. So soil organic matter, and I think I pointed out that this is the quality of soil that says that it's healthy. So it's the microbes, microorganisms, all those micro tiny things. And how you know that it's healthy, you will see worms in it as well. Other all types of bugs, critters, as my mom calls them. You'll find all types of things in the soil if it's healthy. If it's a healthy ecosystem for life, you're gonna find a lot of things that are alive in it. I think that makes sense. Acidification, this was, so soil organic matter is with regard to the geosphere. We talked about soils as the main thing. Acidification is, this is with regard to the hydrosphere. We talked about the oceans, and the more carbon dioxide that is in the atmosphere, the more is being absorbed. Yeah, and so therefore the oceans are becoming more and more acidic, and that is altering their ability to continue to absorb carbon, to continue to be carbon sinks. At some point, they start to release that carbon, also affecting the life, sea life. There's a lot of life in the sea, a lot of life. And in a really big way, that life is being affected, from coral reefs to algae to, as you can imagine, everything and anything, fish. Yeah. Desertification. This is again to do with soils. So we're talking about the soil organic matter. We are talking about the ability to hold water. We're talking about releasing carbon. As it releases that carbon, it gets drier and drier. You're heading towards desertification. The part where the human has influenced is where we're using pesticides and agriculture really toiling. I think I mentioned that. Next point, biodiversity loss. This is, generally anything that's alive. And the basic things are, if climate change is affecting food sources and water resources, then unless humans are lucky, we're very highly adaptable. Animals might not have the same level of adaptability, so they're facing a very different kind of challenge than we are. We know how to call someone up, we know how to set up supermarkets where you can go and buy water for, and you could import that water. These animals, that kind of, that sense of, it's just communication. It's building on communication and interaction. Animals don't have that. They can't talk. I think I said it some. Anyway, I watched something that, it was a podcast I was listening to. Stephen Fry mentioned something about communicating, and that animals, even though they can communicate, it's limited. But also something that I found interesting and I'd never thought about is animals don't know how to talk about, they don't know the context of yesterday and tomorrow. the let's meet tomorrow. No, it's let's meet now. It's in the present. There's no context of past or future. So communication is very limited. There's no organizing amongst each other so that if there's water in the Arctic and there's a locust in the Sahara Desert that needs water, there's no way of a polar bear and a locust having that conversation. But somehow with globalization, we can, I'm extrapolating a lot, yeah, but just give you an example. We can get things from anywhere in the world, just need to literally, we've made it easy for ourselves. Animals are not nowhere close. Yeah, we have to bridge the gap for them. And where we are being the problem and the cause of the problem, we can also solve it. And if that's too much a task, we can make it easy for animals to adapt or just to live in the conditions that we have now. This air quality is also something I talked about with regard to climate change and how that affects the atmosphere. Yeah, so we're talking about the more parts per million and how that's affecting the air we breathe, our health, and the ability of air to move so freely, and how that could move particulates that are harmful from one place to another, so air pollution as well. All the result of climate change because of the different ways that wind systems move. So as I come to my conclusions, I did not think I would last 2 hours, but I have somehow. Climate change, and I think I've discussed feedback loops. So that's the reinforcing of the already warming that's happening. Talked about climate change and that being related to human activities as a whole. We're responsible for climate change, and we are in a position to change that. Yeah, I think I would like to leave it at that. And, it shouldn't sound alarmist when you listen to some of these things. It's good to know. It's good to know. It doesn't matter how bad something is. When you know, you're in a better position to adapt, to help yourself, to help other people adapt. Why wouldn't anyone want that? I feel like it's important to know. And yeah, I will talk about climate action later, but when you know, and like I mentioned, behavioral change follows, these things we call action, climate action, anything that you do in response to reduce the risk, to make other people aware, all of that reduces your own anxiety, just in case that this information is making you anxious. If you do something about it, it reduces anxiety. That's scientifically been reported that if you're worried about someone coming to steal from your home, if you do something about it, you put a lock on the door, you'll be inside the house and knowing that you're better protected. Sort of the same thing. Yeah. So I'm just going to give our highlights of what we're going to cover in the next class. A preview of what we'll cover in the next class. So next Saturday, we'll look at carbon inequality. When we talk about carbon inequality, it's mostly to do with the global north and the global south. and the disparities there. There's it's the difference between developed and developing, huge gap, and that gap, you could say, is due to carbon activities that have led to the carbon inequality. And we'll also look at climate activism, because most of it is pegged on carbon inequality in one way or another, because it's to do with fossil fuels. Yeah, and if you feel you need more depth and practical application exercises, you can sign up for it's a paid bootcamp. Just look for Laba and find our e-store. You're going to find the details. You can also write us, tag us, also tag Village to Nation, for having brought this class to you. You can give us at I am Laba, that's on Pinterest, on Instagram, and on Twitter. Give us feedback on the class, or simply tell us what climate change means to you after the class that we've had today. Finally, you can also find these classes on Lotboy's YouTube channel. We'll upload them there. Expect them from after this class, but also we'll have them on the Village to Nation website, because we'll build onto that this class for our next sessions. So you will find them as a resource on Village to Nation. So see you next Saturday, same time, same place. And just to confirm, you can check the website just in case some details change. And have a great week.